And last but not least, there are systems that are proposed where you can make more than one. In our ideal solar cell, we only made one electron-hole pair per photon. What if you could make more than one? And there are processes that are proposed for doing just that. If you do the thermodynamic efficiencies on this thing, you end up with a potential for a multi-junction. This is an infinite number of multi-junctions of 86%. You know, if you just do the Carnot cycle, you end up with, in theory, 95% of the solar spectrum. If you can do all these other things, you see the range of efficiencies that could be possible with them. And really, this is still in the research labs. This is not out there in the market. Intermediate band cell, and this is my favorite one. It's a quantum dot cell, and that's what I make. And I make it in the 3,5 materials. I use gallium arsenide for the P and the N. I use indium arsenide for the little dots. And I use N-gap material for the intrinsic layer, insulating layer that separate the dots. Polycrystalline thin films, well, there are all kinds of other approaches to those. I'll just, these have a lot to do with geometry. They have a lot to do with the materials that are used in these cells. And so there is potential. There is potential to be gained in the thin film arenas, in the polycrystalline thin film cells. Is that going? Let's try again. Here's silicon quantum dots, and they've actually shown this luminescence of the dots, and they can change the energy spectrum, and we've done this with our cells, dependent on the diameter of the dot. Well, let's dream on, shall we? Let's make them out of a biological process. So biomimetics kind of insertion into the photovoltaic world. And there are, in fact, people who are actually looking into this. By and large, photosynthesis is a relatively inefficient process. Okay? So you may want to take some parts of the photosynthesis structure and actually mimic those in producing a new type of solar cell. And these, again, research products. And last but not least, and I'll do this very quickly, manufacture by design. Actually look at the design of your manufacturing process. Look where you can reduce waste. Look where you can optimize products. Automate. Manual labor is expensive. Keep the influx of R&D concepts and have them go to the manufacturing process more rapidly than we have historically done in the past. So now we're back to where we started. We have an overview of what's out there in the photovoltaic world. And really, how could we have known? When we put up Vanguard 1, we had no idea that we'd be looking at the Olympics live through satellite transmission from Beijing, China. So there's a whole story to be had. We're at somewhere, I would guess, in maybe the first third of the book. There will be more to be written in terms of the photovoltaic cells and products that are used in the future. And why don't I stop there? There's plenty of stuff left, but that's a good portion of it. And see if I can take some of your questions. Thank you. Yes?
What are the biggest challenges of getting solar arrays attached to the grid here in the United States? My students always ask me, why can't we just put it all in the Mojave Desert and, light up LA? And, I have a little bit of insight to that, but, tell me a little more.
There are a number of problems. That's actually a very big issue and something that the industry as a whole have been concerned about for some time. There is, in fact, a proposal to do just that, put all the solar arrays in northern Africa and transmit the power to Europe. Now, one might envision doing that. Of course, why we don't do that is transmission losses in copper wire, right? We have, in the U.S., a rather archaic grid structure at the moment, things that will have to be updated as time goes on. The question is, and this is really an interesting question, the U.S. is, quote, the United States. Basically, each state does its own thing in terms of the regulations that it provides for whether you can hook your photovoltaic array up to the local grid. And they give the local grid a lot of discrimination in the subject. California, of course, has made great strides in doing just that. And they've done it by regulating the industry itself in California. Well, what might you work on if you were interested in solving this problem? Well, you're going to have to work on some of the technology to actually look at using distributed power generation on a grid across several states, because we are interconnected via multiple states. We're going to have to look at putting things in the desert. Actually is a wonderful idea. Let's make a superconducting, if you will, transmission line. Well, there are obvious reasons why we don't do that, but we might. What would it take? Well, a higher temperature superconductor, one that wasn't too fragile to put into a transmission line. So there's a lot of room for research there. There's going to be a lot of policy that needs to be done to upgrade our grid-connected systems. It's really very pathetic. Hurricane Ike went through, as you all know, I believe you got a little bit of rain here, and wind. It knocked out the power in Cleveland for some areas for a week. Okay, that's not necessarily a good grid system. Okay, there's a lot of issues evolving, and also what you do see in the evolution of the utility market is you see people turning into generators, and then you see another set of people maintaining the transmission lines. And as a result of our, quote, deregulation, if you will, of multiple industries, we sometimes end up with sort of a patchwork quilt of how we interconnect our grid structures. You could do a lot more with photovoltaics if you had centralized storage. Well, where would you store it? Up a mountain. Water up a mountain. You'd pump water up a mountain, let it fall back down again. Nice, efficient way to generate electricity. Well, where have you got mountain range? Got mountain ranges in the east along the coast. It is close to population density. You've got the Rocky Mountains in the west. Unfortunately, I have nothing in the middle. It's a real problem in the middle. No, it's an excellent question, and it has a lot of answers to it. There are a number of issues that have to go along with this grid generated power. We need to get away, perhaps we need to get away from the concept of utility generation. Maybe we need to think more of a distributed generation system. Certainly California is moving in that direction. PG&E, Pacific Gas and Electric in California, is a very far-reaching utility company. They've looked into putting in more renewables, both wind and solar and geothermal, because they actually have some geothermal power out there. Geothermal is very restricted, but there are multiple answers to the question. The real Bottom line is, which one will be the best, or will they all be utilized and somehow interchanged? And that's probably going to be the answer to the question, but not without a lot of work, in my opinion. I hope that helped.